In the last video, we showed you how to use the Arduino to turn on a transistor and then had the transistor turn on some high-power devices like this motor, a buzzer here, even one of these incandescent light bulbs. We wanted just to rehash what that sort of was about here because it's sort of an important concept. So we all know and love the Arduino, and one of the reasons that we like it so much is that the programmability that it has just really affords a lot of flexibility. You don't have to hardwire your electronics ideas, you just program them in software, and you can interact with the outside world with these 14 digital input-output lines and 6 analog input lines. It's very nice to have these things around. But one of the issues of the Arduino, it's not a very high-powered device at its core, and neither are any other sort of devices like this here. Any sort of interface box you're likely to encounter doesn't supply a lot of power. It's just sort of to handle the basic logic in here. So in the case of the Arduino, these digital output lines can supply 5 volts when on and up to 40 milliamps. So if you can do something with 40 milliamps here, then I suppose just go for it. But there isn't a lot you can do. There is not a lot you can do with just 40 milliamps. So what we do with that, and this is very common in the Arduino world, is we use the small amount of current not to run the devices we want to run directly. We're not going to use the 40 milliamps to turn on the buzzer. We're not going to use it to run the light bulb. We're not going to use it to run the motor. These things require too much current. What we are going to use the 40 milliamps for is simply to turn on a transistor. We're going to use the 40 milliamps here as the current in the base emitter loop of a transistor right here, which we've discussed in some other videos here, can be a very small amount. It doesn't take very much to turn on a transistor. And the 5 volts here is usually more than ample to ensure that the voltage on the base is greater than the voltage on the emitter plus the 0.6 volts. We've discussed this a few times as well. And in most of these examples, we're always grounding the emitter. So the emitter is at 0 volts. So all we're really focusing on here is, can we get the voltage of the base to be above 0.6 volts? And can we inject a small amount of current? The Arduino is perfectly capable of doing that in just a lot of cases. So if you can do that, of course, then the transistor will be on. The transistor will turn on. It's supposed to be an N there. And what on means in this case here is that the current that can travel between the collector and the emitter, that will start to flow. You will open up a conducting path between the collector and emitter pins of the transistor, and it can start to flow. So see, the Arduino can control when current is allowed to flow through the collector emitter branch. The Arduino can do that. So what we'd like to show here is that the way we've connected this, and it's fairly common to do that, we come in here out of some power supply. I'm calling it plus V. I'm not even tapping into the Arduino power system at all for this here. Plus V can come from anything we want, and this is the real power over a transistor here. We can use like a 9-volt battery for this. A 9-volt battery can supply a lot more current than an Arduino can. Or if we want to go to some other battery, we could easily go to sort of a C cell here, or a big lantern battery, whatever. We don't need to tap the two things on together. We're going to come out of that and go into the device we want to power. But see, as the line comes out of the device we want to power, the device will not turn on unless this side of the device can somehow see ground over here. And so what I'm sort of neglecting to put on here is also that if you have another power supply like a 9-volt battery like this, there's 2 leads on the 9-volt battery. One is positive, one is negative. The positive lead of the 9-volt battery is the one we connect to plus V over here. This is the current that we would like to surge through the device when the transistor turns on. The negative over here needs to be connected to the same ground as the Arduino over here. In other words, all of these things here have to have a so-called common ground. We want them all to reference 0 volts in the same way. So we're not saying the power supplies are linked, we're just saying that they have the common ground. So the 9 volts of this battery is found to be 9 volts relative to the same ground that the 5 volts from the Arduino pin is used to determine that it's at 5 volts. We need that to happen, and that's the common ground between the two. But as you can see here is when the collector emitter branch is turned on by transistor action, the current can flow out of the more powerful battery through the device, through the transistor, on into ground and back into the battery right there. And that's how you get the higher amounts of current that can pass through devices needing that kind of current. So just keep that in mind here as you proceed. Whenever you need higher current, the Arduino or any other sort of interface box just isn't going to be able to supply it to you. The transistor sits in between and moderates it. All the Arduino does is gets a base emitter current flowing in this little loop right here. And when that happens, when that transistor turns on, there will be a much larger collector emitter current flowing here. So this will be a very large current right here. As we said before, this one right here is going to be really small here. But that's exactly what the transistor likes to do, sit and moderate current interactions like that, and the Arduino is very well suited to do that switching action for you. So we can turn on the high power devices, and keep in mind that the plus V over here was an entirely different power source, did not come from the Arduino, and that's another advantage of the transistor. As long as the grounds are the same, the plus V's and things used to bias the transistor can come from entirely different power sources, even something that plugs into the wall. You can theoretically switch a lot of current with these things, with these transistors. And so there you go. That's the power between pairing the Arduino and the transistor.